going to show you how to determine your correlation coefficient and your regression equation on your TI-84. And this was, a scatter plot that I did in the other video, and this is the paired data that I used. But we'll start over again just in case. If this is the paired data and I want to determine the correlation coefficient and the regression equation, all of that is in the same place. You're going to go to stat and you have to edit to input the list, right? So I already did that. So L1 has my X values and L2 has my Y values. So input that into whatever list you want to be in. Make sure that you remember where you put it, right? All right, so second quit to go back to my home screen. Now, there are different ways that you could find the correlation coefficient, and there are different different ways that you could find the regression equation. I like to go to this particular place because it gives me a lot of information in one shot. So stat and over to test. So this is where you would go when you're doing hypothesis testing, confidence intervals and such. I'm not doing that right now. I want to scroll down. I'm going to go down and I want to go to LinReg t-test. LinReg t-test. Linear regression t-test. Because this is also going to do the hypothesis test for row as well. And when I go into LinReg t-test, I have my X list, my Y list, a couple things they ask me. Again, my X list was in L1, so second and number 1 to pull up L1, and my Y list was L2, so second 2 to pull up that. I'm going to leave frequency 1. It doesn't matter it doesn't matter which alternative hypothesis you have here. It does if you're actually running a test. It doesn't if you're just looking for the correlation coefficient. So you could leave it as a two-tailed test, but if you're actually running a test, then you want to determine, or you want to write out, excuse me, you want to highlight which one you're actually doing. Skip everything, you don't need anything here, calculate. The reason I like this is because it really gives me a lot of information. So you can see that it gives me, the type of test that I ran, if, it was two-tailed. It gives me the test statistic. The test statistic. It gives me the p-value. It gives me all of that. And then here, it gives me the regression equation. So y equals a plus bx. So the slope is b, 6.4, and the y-intercept is -22. So you can write out your equation from there. And then if you scroll down, it gives you your correlation coefficient, and then it gives you your r squared. So just this one location has a lot of information. Like if I wanted to do an actual test, I could do it here. With the p-value, I could determine reject the null. So there is a correlation. I could look at the correlation coefficient, talk about how strong or weak, positive, negative. I could look at r squared. I can actually find the regression equation here as well and write it out. Y equals 6.4 x plus or minus -22. So everything is in this one place, LinReg t-test. So stat, test, scroll down, and however it is that you get to LinReg t-test as fast as you can, input your stuff. If you are doing another test, you could do left-tailed, right-tailed, and then calculate. So obviously the p-value changed because I made it a left-tailed test. Obviously the test statistic changed. I made it a left-tailed, I don't think it changed, whatever. At the end of the day, what I use this for with my students is I show them, I like to, especially for this is really just an introductory statistics class, right? So I use LinReg t-test to basically talk about, I think we might do left-tailed and right-tailed, but I like to do two-tailed. And then, I can run the test here for row, and then I can also determine, if I want the test statistic. I don't think we use test statistic. We really only use the p-value method when we're running a test for row in this particular class. But I can determine the regression equation and I can determine the correlation coefficient. If I want r squared, I can do that too. So everything is in this one spot. So I like to tell my students to look at the p-value to determine if they're rejecting or failing to reject the null hypothesis, which would tell them if there is a linear correlation or not for the population. and then look at the correlation coefficient, determine if it's strong or weak, and then positive or negative. You get your regression equation from here as well if you're asked, and you can even look at the graph to correspond or to go with what you see for your statistical values. Now, that's what I use that for when I teach linear correlation and regression. That's kind of the gist of what we do here. We don't go too deep into it. So that's what I use this for.